Good afternoon. This is Team 19 for Airbag Design for EML 4501 Mechanical Design 2. I'm Dennis Moreno.
I'm Kristopher Vinas.
I'm Juan Herrera.
I'm Alexander Gill.
We're going to start off with the history with Juan Carlos Herrera.
All right. Between 1960 and 1965, 30% there was a 30% increase in accidental deaths due to motor vehicle collisions. In 1966, the Highway Safety Act was passed by Congress, and also the National Highway Safety Bureau was created, which mandated change in vehicle standards, which also made each state have their own highway safety laws. All this was needed because as more cars were coming into the roads, there was going to become more and more accidents. President Lyndon B. Johnson had this quote, "We can no longer tolerate unsafe automobiles." And airbags became mandatory by January 1st, 1973. But these deadlines was pushed back until 1976, and eventually it kept on being pushed back because of the safety risks that were continuing to happen with the airbags. But the seed was planted for the need for airbags. And John W. Hendrick was the first person to come up with a patent for the airbag. He was a retired industrial engineer. He came up with the idea, and he called it the safety cushion assembly for automobile vehicles. He was awarded the patent in 1953. This is the patent number, and this is a schematic of the patent number, of the patent that he created. He was not the only one to have a patent. Walter Linder also held a patent in Germany. This is the patent number he had, and it used compressed air. Also, we had a Japanese inventor. He also created an airbag system, it was awarded patents in 14 countries. And this one is the one closest to the models that we're using today. Alan K. Breed also had a patent for the airbag. He was the first to create an electromechanical automotive airbag system. He was the first to use sensors to detect the collisions in order to let off the airbag, to deploy the airbag. Ford and GM were some of the first to go into the airbag business. GM vehicles were linked to 7 deaths in collisions involving vehicles with airbags. And in 1974, there was one direct incident where an airbag was the cause of the death, which a lot of automakers tended to abandon the idea of airbags because of these safety issues. Mercedes-Benz, though, continued on the development of their airbag, and in 1981 unveiled a perfected working system. They used over 250 fully functional automobiles and tested them, 2,500 mock sleds that crashed to test to see how the airbag would work, and they also used canaries to test the sound, which would be let off when a deployment. They also were the first to have the side impact airbags in 1995. Now Chris is going to talk to you guys about current airbag designs.
The current design of airbags can be broken down into 2 parts: the airbag control unit and the inflator unit. The airbag control unit is pretty much the trigger, if you will. It's a microelectric mechanical system that monitors a whole bunch of sensors. It also has some sensors built in, accelerometers, gyros, speed sensors, and then on top of that, which those are pretty much included in the module, it also monitors speed sensors, brake sensors, pressure sensors in the doors, all along the vehicle. It basically takes all the information gathered from these different sensors, and using an algorithm, it determines the angle of impact and the force of impact. It then uses that information to deploy the airbags accordingly. So that whole process takes 15 to 30 milliseconds to complete. Once it makes that decision, it goes ahead and sends the signal out to the inflator unit, and also on some vehicles that are equipped with slack removal devices for the seatbelts, it does that as well. The inflator unit contains the propellant, the bag, and the igniter. Once it gets the signal from the airbag control unit, also known as the ACU, then the pyrotechnic reaction begins. So the initiator, which is basically a conductor wrapped in a combustible material, electricity passes through it, it gets hot, and the combustible material around it combusts. This goes ahead and ignites the propellant. Now this causes a chemical reaction which very rapidly produces a gas, mostly nitrogen, and that's what inflates the bag. That whole process of inflation occurs within 15 to 30 milliseconds. All in all, everything happens in about 0.04 seconds. Besides the nitrogen, there's also talcum powder in the bag for lubrication, and the bags are commonly made up of nylon. They have large vents, so as soon as they inflate, they're able to disinflate, and the only thing that comes out is basically the nitrogen and the talcum powder. As far as regulation, airbags are required standard on all vehicles since 1997, and it's regulated by the National Highway Traffic Safety Administration. Basically, the way that it's written, that airbags be engineered and calibrated to be able to save the life of an unbelted 50th percentile size and weight male crash test dummy. That's the minimum requirement for them to pass. Next, Alex is going to talk to you about some future airbag designs.
Well, the future developments of airbags are based on 3 improvements. Testing, which is from static testing, and I show over here a slide of the airbag coming out of the front driver steering wheel, where they can evaluate how it comes out at the speed. Is also tested with dynamic testing, which you can see by the motorcyclist, driving into another vehicle at speed. The development of airbags are improved through the testing. It's improved by different sensors, new and improved technology. The newer sensors come out, the better it gets. There's new placement of airbags are also another development of the airbag. For example, Toyota IO in Japan have rear curtain airbags. Coming out in 2012, Toyota IO is the first vehicle who has rear curtain airbags. Rear curtain airbags are implemented to lower head injuries. They're actually in the back of the headrest. For the airbag on the passenger side is a design created by TRW called Bag in the Roof. This improves the injury rate because previous designs, it came out of the dashboard, and on the dashboard it would have a long area to come out and help the passenger with a crash. This one comes out of the roof. It's easier to put on the car. Multiple cars can have it, the same design, so it is also cheaper. Other completely new designs to the airbags can be created. For example, Ford's seatbelt airbag is aimed to increase the area of contact between the passenger and the seatbelt. What it does is all the stress, the force from the airbag on impact would not hurt the passenger. Also, Saturn's new design called the jump belt, which is shown on the bottom. It is an airbag that is released off the shoulder of each passenger, and it would act as a harness. So imagine being a roller coaster, and it'll hold you back from being projected forward. Other vehicles that use airbags are vehicles such as motorcycles. Another design is what NASA created over here, which used airbags on helicopters and space vehicles because of their great ability to absorb shock. This test specifically was a helicopter dropped from 45 feet, and they studied the impact of 45 feet drop to the ground. Airbags are also used for suit designs. Recently, company Dianese made 2 suits, one on the top here and one on the bottom. The top one is called a D-Tech inflatable airbag, which acts as shoulder pads once the motorist is launched from his motorcycle. It deploys it and protects the most common injury of collarbone fracture. Another design is the bottom one, which D-Tech calls it the D-Air ski vest, which is used in Canadian and U.S. Ski teams currently, and it helps them from injury. Airbags have even been getting into style. Many European countries ride bike all the time, and one company actually made a fashionable bicycle airbag helmet which you can see on the bottom. Once the cyclist is struck from a car, the airbag is deployed and saves lives. And in conclusion, we're going to have Dennis to wrap it up.
The airbag design has been under development for over 35 years, and since its introduction to the automotive world in 1971 with Ford and GM, it was only up until 1997 when it actually became mandatory for all cars to be sold with the airbag system. And even though there are still improvements to be made, the airbags have actually gone through a long road and many iterations before they got to the system that we know today. A key part to safety and the well-being of passengers in the vehicle. And as important as they are, they're only the secondary system to the whole safety system of the car. And so it kind of like ties them directly links them to the lives of the passenger. For that reason, why it's very important, and it's actually imperative that the airbag system is actually a robust system. And companies actually focus a lot on the algorithms. Those are actually proprietary to their airbag systems, and basically what the algorithms are for is to match the deployment times in conjunction with the airbag sensors placement and everything like that. So basically is actually what's the most sophisticated part of the whole entire airbag system. And as airbags continue to grow and develop and become more sophisticated, we can continue to see them expand into other realms of the vehicles, such as we saw bicycles and motorcycles, possibly watercrafts, and maybe even sometime in the near future airliners. So, as we know, airbags are going to be around for quite some time. And that is my conclusion to this presentation. I'd like to thank you for your time, and thanks.